So our shortcut derivatives, right? So if y is some constant, right, we know that y prime is 0, right? Because y equals c is a horizontal line, and the slope of that horizontal line is 0. If f of x equals mx plus b, and I take the derivative of f of x, which should be equal to the derivative of mx plus b, on the left, what do I get? Here in green, what do I get? F prime. And on the right, I get m, right? Derivative of mx is simply m. The derivative of b is 0. If I tell you that I have y equals x to the n, and I say I want to take a derivative, the other way to say take a derivative is use the prime symbol. What do I get on the left now? Here's the left. What do I get on the left? Y prime. And on the right, n times x to the n minus 1. Nice. So for example, if y equals 3x to the 4th, what is y prime? Nice, 12x to the 3rd. Notice the 4 times 3 is the 12, and then the exponent of 4 reduces by 1 to 3. Right? It's really that simple, right? If y equals 1 over x squared, what's y prime? Well, it's not so easy to do this one in your head, but if you rewrite it first, this is x to the minus 2, right? So what do I get for y prime now? To the minus 3. Nice. And that negative exponent means move it downstairs and make it a positive exponent. It means reciprocal. Y equals sine of x implies y prime is cos of x. So, for example, let's get the tangent line at, let's say, 5 pi over 6. Right, so I want to draw that tangent line, right? I want the equation of the tangent line. What is sine of 5 pi over 6? What's sine of pi over 6? 1/2. So this is still up in the air. Remember, sine is a y value, so it's still 1/2. Right? Sine is giving you a height. Cosine is giving you an x, a width. What's the slope? Say again? Nope. What's the derivative? Cosine. So I need m is cosine of 5 pi over 6, right? Which is negative what? Yep. So my tangent line is y minus y1 equals m times x minus x1, right? That's from algebra 1. That's the end of algebra 1, right? Point slope form. Make it your friend. If you only like the y equals mx plus b one, let's go. We're out of middle school now, right? We can use this more. This one's more sophisticated. So what am I plugging in? Y minus what? Yep, y minus 1/2 equals Nice. Negative rad 3 over 2 all times x minus 5 pi over 6. I want my answer, when I ask for a tangent line, I want it as a y equals mx plus b. So y minus 1/2 equals negative rad 3 over 2 times x plus 5 pi rad 3 over 12. And then I'm adding 1/2. Sorry, 12. And obviously I need an LCD, so I need 6 over 6 to get to 12 downstairs. So final answer, y equals minus rad 3 over 2. Get Desmos loaded for me, okay? Plus 12 plus 5 pi rad 3 all over, 6, right? So on Desmos, I got sine of x. I should see my 5 pi over 6, comma 1/2. Nice. Right, I'm making sure it's hitting the curve, right? And then my tangent line is coming from y equals negative square root of 3 over 2, times x plus 6 plus 5 pi rad 3 all divided by 12. And there's my tangent line. You okay here? Yes. Nice. We okay? Say again? 1 second, sure. I'm Polish, not Russian. If I'm going too fast, slow me down. You're paying me. I'm your Uber driver, right? If your Uber driver's going too fast, don't wait till you get home and then write a bad review. Tell them now. Do you mind doing the speed limit? Right? So, from doing what?
I got PTSD from doing minimum wage jobs. I have to do so many different things for different people.
Yeah. It's tough. I know. I did it. All through college I worked. Worked in a restaurant, painted houses. I taught guitar. We okay? This one's not dynamic, right? This tangent line's not dynamic. I can't move anything, right? But that's fine, because when you're checking yourself, you want to make sure, one, that you got the right point, two, that it makes sense that, we have what we have. Like watch for example, if I take off this negative here, right, on my slope, I clearly see it's not right, yeah? If I accidentally had a 12 here instead of a 6, right, you can really see if you made a mistake, it should right? And then, of course, you're zooming really close to the point, right? We're trying to get within what of the point? Where are we trying? How close are we trying to get? Say again? One more time. Exactly. And so what are we thinking about? We're thinking about within delta and within epsilon, right? And remember, epsilon can go all the way to what? Nothing, yeah. Right? So close to zero that it looks like zero. So close to Earth that when you're looking out at the ocean, you see a straight line, but in actuality, it's curved, right? Yeah, you agree? Unless you're a flat Earth person, right? The horizon is actually a curve, but we're so close to it in terms of relevance to the Earth, it looks like a straight line. This is the essence of calculus. Straight lines can take the place of curves. Straight lines are easy to deal with. Y equals mx plus b, right? Shortcut. If y equals cos of x, what is y prime? Yep, negative sine of x. So let's do a cosine at minus pi over 2. Of course, you already know what the slope is there, don't you? What is it? 1. Because it's just the sine curve moved over, right? We know what the slope of the sine curve is at 0. It's 1. So if I move the sine curve over, I get the cosine curve, right? So it's pretty clear here, right? That also I've got what? Minus pi over 2 comma 0, right? And my slope is minus sine at minus pi over 2. So that's a negative times a negative 1. Which is 1. We agree with that? Everyone agree with this? So our tangent line is y minus 0 equals 1 times x minus a negative pi over 2. So I get y equals x plus pi over 2. That's my tangent line. Is everybody with me? Am I going too fast? We're okay. So on Desmos, I like opening a new window because I don't have to worry about the stretch. You know, when I start stretching the window, it's nice to go back to that original setting. So just opening a new window makes it easier for me. So y equals cos of x is my original curve. I have the point minus pi over 2, comma 0, making sure I've got the right point, yes, right? And I have the tangent line, y equals x plus pi over 2. Boom. Are you typing it in? You could watch me parallel park. It's not the same as you parallel parking. I'm a city boy. I can do it just one turn in reverse. No back and forth to get into the spot. You could watch me play guitar. Does that mean you can play guitar? Probably not. How are we doing? You need another minute? We okay? Nice. Shortcuts. If y equals e to the x, y prime is what? Anybody know? Huh? E to the x. This is a pretty special function in that the derivative is the original function. What does that mean? This is y equals e to the x. So for example, at 1, our coordinates are what? 1 comma what? Say again? Yes, I like e. E to the 1 is e, right? It's 2.72 approximately. What's the slope there? Yeah, e. The height of the function is also, at any point, is the slope of the function at any point. The height and the slope are identical to each other. Pretty cool. The number e is named after Euler. I don't know if you know who Leonhard Euler was. He's a 16th century brilliant mathematician, came up with all kinds of theories and proofs and things. So what's our tangent line here? Someone read it to me. Y minus what? Y minus e equals e times x minus 1. Nice. Cyril, I got your quiz over here. I'll get it for you. I got it. Okay. So I get y minus e equals ex minus e. So I get y equals ex minus e plus e. Haha. Y equals ex. That's a new shortcut. I didn't have that one before, right? So that's a new one. Got to memorize them all. Got to have them on our formula sheets. Let's do it on Desmos. So there's my curve e to the x. I had the point 1 comma e. Nice, it worked, right? And my tangent line became y equals ex. There it is. Ha! Gotta love it. So it's so cool to be able to know you're right. Isn't it nice to know you're correct? That's one of the things we like about math, right? You know when you got it. You got to be okay with, when you don't have it. You got to be okay with that. And then use your brain, use your intelligence. Write things, graph things, try things over, ask for help. Right? We have to get used to asking for help. If f of x is ln of x, what do we say f prime was? 1 over x. Beautiful. Let's look at the point. When x is 1, right, I get f of 1, which is ln of 1, which is what? No. Yep, 0. And then what is our slope? Slope comes from the derivative, right? So, and at x is 1. So f prime of 1, or 1 over 1, which is 1. So if we look at that curve, ln of x, at 1, 0, I should have a tangent line with a slope of 1. Find me my tangent line, please. Cyril, you need a pen or something? X minus 1. Y equals x minus 1 is a tangent line. Woohoo! I love it. Usually when I'm arguing with my girlfriend and nothing I say is right or nothing I'm doing is right, I will just say, I'm going into the office and I'll just go do math problems so I get to be right every now and then at home. She's like, you got problems. I was like, yes, I got a whole book of problems. Yes. Yes. Yeah, so if I give you an x coordinate, right, you need a y coordinate on the curve. So I plug my x coordinate into the original function to find the y coordinate.
So ln1 equals 0.
Yes, is the y coordinate, yeah. Remember, f of is a y, right? Y equals f of x is a y value. Nice, right? Pretty cool. So other functions are not so easy. We need a couple of things in order to, right, we need to learn a couple other things. The main thing we need to learn is the chain rule. That's the tough one. Peter, yeah. I can see it to see. Wanting to call you. So I I'm recording. No one had questions today, so I'm just going over shortcuts. Now let's go over long cuts. Okay? Let's say f of x is square root of 2x minus 1. Does anybody know f prime? I doubt you do, but maybe you do. Maybe you remember the chain rule. Anybody know this derivative just by looking at it? Hmm?
Would that be, so the 1 over 2 from 2x minus 1,
Yeah.
or no, I'm talking about from, well, yeah, and then after that, so the decimal where it goes, like the derivative of
Inside
yeah, and then derivative of the inside.
is 2.
Yeah.
So there it is. That's our derivative. I'm doing the chain rule there when I'm doing that. But we're going to do it now with our limit. Right? Please don't just copy me. Please write the problem, okay, and do the problem. Don't just copy me. So, yeah, we're learning it. It's in section 3435. That's the one that's going to bite a little bit. But basically, so let me talk about the chain rule. Okay, don't write this. Remember how we said y equals square root of x, y prime is 1 over 2 square roots of x? So notice I got the 1 over 2 square roots of whatever was inside, right? We did that at the end of the day yesterday. I said the derivative will keep the shift, right? But now if you look at the inside function, 2x minus 1, that itself has a derivative of 2. I then need to multiply the derivative that I got by the derivative of the inside. That's the chain rule. So I multiplied by another 2, and then the 2's canceled. Don't worry about that yet, okay? All right, here we go. Long way, long cut. F prime of x equals the limit as h goes to 0 of what? Beautiful. 2 times quantity x plus h, all minus 1, minus the original function, square root of 2x minus 1, all over h. And this is the piece that I wrote on all your quizzes. If you want to, you can keep writing limit over and over. Equals the limit of this function, equals the limit of this function times the conjugate over itself, equals the limit of, et cetera, et cetera. You can keep writing limit over and over if you want to. I don't like to. I'm lazy. So I want to work on the function itself before I go back to my limit notation, right? So I'm going to say star is square root of 2x plus 2h minus 1 minus the square root of 2x minus 1 all over h. And then from that, I'm going to do the conjugate. once I get my replacement function, anybody get there? I know, I'm going a little fast. I feel like I had too much coffee today or something. Tia, yeah? You got there? Thanks. So now, this is star, and I'm doing the limit as h goes to 0 of star. Once I plug in with the 0, I don't write the limit anymore. I get 2x plus 2 times 0 minus 1, all plus the original function, right? Once I fill in for h, I'm no longer asking, hey, what's the height? I know the height, right? Or I'm no longer asking, what's the secant slope? I have the tangent slope now, right? So what do I have now? I have 2 over square root of 2x minus 1 plus another 2x minus 1. That's 2 of those. And the 2's cancel. And I finally get it, f prime of x is 1 over square root of 2x minus 1. Yes! Yes, I have mad scrolling skills. Yes. It's a yeah. So it's 2 of them. Yeah, exactly. So wait a minute. You're looking here, right? Okay. So I have 2 times 0, so that's gone. This piece is gone, right? Yep. So I have a radical with the 2x minus 1 plus another radical with the 2x minus 1. So I have 2 rads. So there it is. 2 times the radical 2x minus 1. That's right. Yeah. Yeah. Okay. Nice. So let's look at this one on Desmos. So we've got my original function of the square root of 2x minus 1. You see any interesting points that you would like to find a tangent line at? You see any points? You see any of the vampire points where the curve is hitting a crosshair? I call them vampire points because like you're supposed to put the vampires can't look at crosses. What x value? What? 5 works. What else? 1 works. I like 5. Let's do 5. So when I plug in 5, I get a height of what? 3? We agree? Right? 2 times 5 is 10, minus 1 is 9, square root of 9 is 3. Yes? What's our slope? Well, it's the derivative at 5. So it's 1 over square roots of 2 times 5 minus 1. So 1 over 3. And what's our tangent line? Y minus what? 3 equals 1/3 times x minus 5. Find your voices, people. So y minus 3 equals 1/3 x minus 5/3. So y equals 1/3 x minus 5/3 plus 3. Of course, 3 is 9/3. So y equals 1/3 x minus 4/3. Plus, thank you. Woo-hoo! My teachers would always say they make mistakes on purpose just to see if you're paying attention, but I just make mistakes. So we,
I forgot the name of it. What's the opposite of whatever like what y prime is? What's it called again?
what?
What's like the thing y prime is?
Y prime?
Yeah, or like the equation. I forgot the name of it.
Oh, this guy, y minus y1 equals,
Y prime.
yeah, no, y1.
Yeah, y prime.
Yeah, this is called the point slope equation of a line.
Oh no. I mean like the equation used to find 1/3.
Oh, that's the derivative. Yeah.
Forgot.
Yeah, y prime is f prime. Interchangeable. So y equals 1/3 x plus 4/3. Oh yeah, baby. Classic. So when I give you a tangent line to do today on the quiz, you make sure you graph it, right? Make sure you double check it. That's it. 4 quizzes today. Every day, except for what day? Tuesday is the only day you don't have quizzes. Every quiz will be at least 2 questions. That's 2 quizzes. One quiz is 1 question. Second quiz is a second question. So 6 weeks, right? 3 days a week. We'll have quizzes times 2. That's 6. That's 36. We won't have quizzes on 4 of those days, the day before an exam and the day of an exam, the day before the last exam and on the exam. So at minimum 32 quizzes. I can. I have mad go back skills. Say again?
Tangent is the same as f prime x or y prime?
So the slope of the tangent, yes. The slope of the tangent is the same as the value of the derivative.
It's just how you want to write it.
Exactly. Yeah, don't let me run you over when we're doing problems. You are paying me, whether it came out of your pocket or your family's pocket or the government's pocket, because they want you to go to school, right? You're paying me. You make sure you get your money's worth. Another one? Say again?
I'm still writing it. Sorry.
No problem, I'll wait for you. I'll wait for you, I'm in no rush. Are you okay there? I am recording it, right? Nice.
So after you did the rate of change formula, sorry, I don't know that.
Yep, yep.
What number you get from it?
So 1, 2, 3, tell me what, 4, 5, 6, 7.
Like 67. What number you get from it?
No number yet, still an arbitrary function,
Okay.
right? Still an arbitrary function, but with an x and an h. Right? So what is this? The slope of a secant line. Once you give me an x, and then tell me how far the next x is away, right? H.
Did you get that 5, 6 that number?
5, 5, 3?
5, 3, yeah.
Yeah, so we had decided that 5 was a nice vampire point. X is 5, we saw it hit the crosshairs. And then we plugged 5 into the original function. 5 into the original function. So if x is 5, y is f of 5, which is square root of 2 times 5 minus 1, which is the square root of 10 minus 1, which is square root of 9, which is 3.
Okay.
Yep.
Like, makes sense, but just.
So I got a curve, right? I find a point on the curve, and then I want the tangent line at that point. Yep. So I need to.
Like, inserting the derivative formula.
Exactly. The slope I'll get from the derivative at the x value. So at 5, f prime is 1 over 3. Right? So I took my derivative, I plugged 5 in to get my slope. Let's do another one. You'll be fine. Let's do another one. Do you need a book to practice these things?
I see the, like,
No, I'm asking in general. Do you need a book to practice this process? Do you need problems to practice this? No. Come up, take a function, graph it, pick a point on the function, find the derivative, find the slope, find the tangent line, graph it. What would I like you to stay away from? Really, really complicated functions. Like right now, you don't know the derivative of tangent. You will soon, so you don't want to use a tangent function. But you know all of the shortcuts I did today, right? You could do any of those shortcuts. But you want to be practicing finding the derivative using the limit. Let's do another one. Oops. So what if y equals 1 over x squared? I'm going to do the derivative of both sides. So on the left, I get dy dx. By the way, that's interchangeable with y prime or f prime of x. And on the right side, what do I get? Do you know? Shortcut it for me? Yeah, negative 2 over x cubed. Yes, negative 2 over x cubed, right? I'm bringing down the exponent to as a coefficient. Then I'm reducing my exponent by 1. This is called the power rule.
The x over next, without an
Say again.
So switching it to x to the power negative 2, that wasn't enough.
That's the function, right? This is the function, right? I want the derivative, right?
Yeah.
Yep, good. Name a point you want to use. Name something in the domain for me. A nice integer point in the domain. What x value am I allowed to put into this function? Anything but 0. So how about negative 2? So if x is negative 2, what's y? One-fourth, yes. And what's m? Yes, negative 2 over 2 cubed. That's negative 2 over 8. That's negative 1/4. Nice. Everybody with me? Michael?
Yeah.
Good. Don't lie to me. No, not okay? Okay, so where are you lost?
Derivative of x is equal to negative 2.
Yeah?
Is it not negative 2x?
No, you got to subtract, reduce your exponent. Reduce, so negative 2 minus 1. So bring down the negative 2 and then subtract 1 from your exponent. So I get negative 2x to the negative 3, which is negative 2 over x cubed. Good. What's our tangent line? Y minus 1/4 equals? Yes. Yes, I just decided. Yep. Yep. 2 to the third. Yeah, remember, I'm plugging into my derivative. I'm plugging that. Oh, you're right. I made a mistake. Yes, thank you. Thank God. Thank God you saw that. Positive 1/4. Thank you. And of course, look at my graph. Shouldn't the slope be positive? Look at my graph. Yeah. Thank you. Tangent line. Tell me when you got it. Nice. Nice.
It wasn't it negative 2?
Oh, jeez. Robert, what is wrong with you today? Sorry, do it over. So it becomes a +2 here, right? Yes. Nice. Let's go to Desmos. Question? You say again? Oh, okay. Yep. Yeah, again, when we're doing stuff like this, when we're doing stuff from 8th grade, I'd rather you don't copy me. Do it yourself. Okay? I mean, it's okay though, right? But I'm saying, in class, you should be not just copying me. You should be doing the math yourself. All right, let's look.
They're not the exact opposite. The graph on this one is like exactly the mirror of the one on the previous question.
Oh, yeah. Yeah. So I've got y equals 1 over x squared. I have the point -2, comma, -1/4, right? No, 1/4, yes? Yes? Nice. And I've got the line y equals 1/4 x plus 3/4. Yeah. Love it. Love it when we're getting things right. And I made a couple of mistakes there, but I would have seen them when I went to graph. I would have seen it. I didn't have the right line. And then I would have been looking and not realized I put in a 2 instead of a -2. And so what's the key there? Brand new piece of paper, start it over. Right? Let's do that same one. Let's get the derivative using a limit. Let's get that derivative using a limit. Ready? Almost? Ready? Almost. Okay, I'll wait. Where? No. This is going right to the tangent line slope. Yep. The secant line, I need what in it? The tangent line, I need an x in it, right? I mean, unless it's not changing. But the secant line, I need an x and an h. Right? I need an x and some distance to the next x. Right? That's the distance between the two x's is h. And I want that h to go to 0. So the 2 points become 1 point. Nice. Here we go. If y equals 1 over x squared, find y prime using a limit. That's what it's going to look like on the quiz on Monday. Oh, and today, right? Yeah, today. What? Yeah, yep. On your market, set, go. Gotcha.
Yeah, but that's a shortcut. You'll have to know how to resolve.
You got to be patient, take your time, right? Make sure you're double checking your algebra.